All right, guys, now time for section 3 of chapter 2, which deals with solving multi-step equations. So last time we solved one-step equations. We just did it by addition and subtraction or multiplication and division. And now we're going to solve equations involving more than one operation. We're going to kind of put those together. And then we're going to solve equations involving something called consecutive integers. And we'll talk about what that means when we get to that second video here. So some new vocab: multi-step equation, consecutive integers, and something called number theory. All right, so the Tour de France is a premier cycling event in the world, and the map shows the Tour de France course. If the length of the shortest portion of the race can be represented by k, the expression 4k plus 20 is the length of the longest stage, or 263 kilometers. This can be described by the equation 4k plus 20 equals 263. So that's an example of an equation that would require multiple steps in order to solve it. Okay, so since that equation requires more than one step, it's called a multiple or multi-step equation. And to solve it, we have to undo each operation by working backwards. Now, here's the thing. We learned the order of operations: parentheses, exponents, multiplication, division, addition, subtraction. That's how you simplify an expression. Well, when you solve an equation, it's kind of like you're unsimplifying it, so you want to work backwards. And that's how you solve an equation, because what you're doing really is you're undoing all the operations to get the variable by itself. That's called isolating the variable. So one of the easiest ways to think about it is to just do the order of operations in reverse. Okay, so let's solve this equation. I have 11x minus 4 equals 29. Now, I have what's happening to x. You got to think. Well, if I put a number in for x, I'd have to first multiply it by 4, or excuse me, multiply it by 11 and then subtract 4. Well, if I'm trying to get x by itself, I want to undo those things. So if I have to first multiply, then subtract to simplify the equation, let's work backwards. I got to get rid of the subtraction first. So you add 4 to both sides. Then you would have 11x equals 33. Then divide the x by 11x by 11. So divide both sides by 3. Forgot to put that on there. So divide both sides by 11, and you get x equals 3. Now, the check is you plug 3 in for x. Like this. So 11 times 3 is 33, minus 4 equals 29, and 33 minus, I wrote 92, did you see that? 29. It is 6:53 in the morning when I'm recording this video, so take it for what it's worth there. All right, 29 equals 29. So since when I checked it, I got the answer I needed, I know my answer is correct. So a plus 7 divided by 8 equals 5. Again, if you plugged a number in for a, you would first add the 7, then divide by the 8. Remember, the fraction bar is a grouping symbol. It groups the problem into a numerator and denominator, and you can't divide by 8 until the numerator would be simplified. So you'd have to add first, then divide. Well, if you're going to reverse all of that, you would multiply by 8 first, then subtract the 7. So we're going to multiply both sides by 8, and these 8s are going to cancel, and you'd have a plus 7 equals 40, and then subtract 7 from both sides, and you get a equals 33. Now, if we want to check it, we substitute the results back into, went too far, the original equations. So if I take a equals 33 and plug it in for a in the original equation, okay, so 33 plus 7, not 4, 7 over 8 equals 5. I would do the 33 plus 7 first, which is 40 over 8 equals 5. And 40 divided by 8 is 5, so 5 equals 5. And we're good, okay? The solution, the answer to the problem, is a equals 33. That's the answer. We just did the check to see if our answer was correct. All right, guys, here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So 1a, we're going to add the 6 first. You have 2a equals 10. then divide by the 2. That's a 10. All right, so A equals 5. And now I'm not going to write out the solution. I'm just going to or the check part. I'm just going to verbally go over it. But if you're asked to show the check, you need to actually write it out like I did in the previous problem. So if I put 5 in here, I'd have 2 times 5 is 10 minus 6 is 4. So it works. This first one, or excuse me, B, you'd have, I'm going to rewrite it first. So undoing things, I'd have to first multiply by the -2 on both sides to get rid of it here. Okay? Then I'd have n plus 1 equals -30. Then you subtract 1, and you'd have n equals -31. Now, if I did this horizontally, it would be -30 minus 1. And remember the rule for subtraction? Always change it to addition by doing keep, change, change. And now it's an addition problem of 2 integers that have the same sign. So when the signs are the same and you're adding, you add the numbers, keep the sign. So 30 plus 1 is 31, keep the sign, it's negative. So -31. Now let's check it. -31 plus 1, well, if I did -31 plus 1, the signs are different. One's negative, one's positive. So I subtract the numbers, keep the sign of the bigger. So that'd be -30. Then divide by -2 would give you +15, and that's the answer that we're looking for. So we know our solution of -31 is correct. All right, so here's a real world example. Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. What was the original price of the skis? Write an equation for the problem, then solve it. So I know that it was on sale for 2/3 of the price. So whatever the price is, call it P, multiply it by 2/3, and that's the price that he paid. But he also used a $25 gift certificate to reduce the cost to him. So you're going to subtract 25. So 2/3 P minus 25 equals 115. So again, if you plugged a number in for P, you'd multiply it by 2/3, then subtract 25. So order of operations in reverse, you're going to add 25 to both sides. You get 2/3 P equals 140. And remember, how do we get rid of a fraction if it's being multiplied by a variable? Correct. You multiply by the reciprocal. So to get rid of the 2/3, you multiply by 3/2, and they cross cancel here. And 3/2 of 140, you could put the 140 over 1, like that, and then cross reduce. The 2 and the 140 would cross reduce to a 70 and a 1, and then 3 times 70 is 210. Okay? And then you could check that answer. So in the original equation, you could do 2/3 of P, 2/3 of 210 minus 25 is 115, and it would work out. Now, since the numbers are in the context of a situation, you have to say what your answer represents in the context of the problem. Since it's money, it represents dollars, and in the context, what are we talking about? Well, we're talking about the original price of the skis, and it was $210. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So Len read 3/4 of a graphic novel over the weekend. Monday, he read 22 more pages. If he has read 220 pages, how many pages does the book have? Okay, so the whole equation is talking about how many pages of the book Len has read. So he read 3/4 of a graphic novel. Now, what's of mean to do? Right, multiply. So 3/4 of the, we're going to use P for pages because that's what we're trying to figure out. Then Monday, he read 22 more pages. So we're going to add on to that 22 because we know the total pages. We know that he's on page 220. Well, he's probably on page 221 because if he read 220 pages, he's probably, the next page he would read would be page 221. That doesn't matter. Anyway, we know he read a total of 220 pages. And since everything is talking about the number of pages he read 3/4 of the novel and then 22 more pages, we can add that together and set it equal to 220. All right? So order of operations in reverse, 220 don't add it. You're going to subtract it. So 3/4 P equals 198. Then multiply by 4/3. Those cancel, and you get P equals 264. Okay. Then if you plug 264 in, 3/4 of 264 plus 22 would give you 220. Alrighty? All right, so that's it for this one. In the next video, we're going to talk a little bit about how to solve consecutive integer problems. So stick around, tune in for that one. It's going to be pretty cool stuff. See you there.